Hello, welcome to this video. This is 4-5, and we are going to graph some derivatives and antiderivatives, which is just graphing a function from a derivative from given graphs. Okay, so we're going to use some different concepts that we've been talking about and applying them into sketching some graphs. Okay, so derivatives. Remember, if we go from f to f prime, what we're doing is we're taking the derivative, right? And the derivative is the slope of the tangent line. Okay, so what we're going to be doing is we're going to be estimating different slopes at various points. So for this first part here, what we're going to look at here is our graph, and we're going to use some key ideas that at 2, we have a maximum. Sorry, at -2. And at 2, we also have a maximum. Okay, and at minimum. At those locations, your slope is 0. So if we're thinking about this, at -2, my slope, okay, and that's f prime, the output is 0. That's the slope. Okay, so I have my mins and my maxes placed there. Okay, and then what we're going to do, we're going to find the slope, okay, and then plot them as points. And I kind of want you to think about this section here, okay, and look at that. So at 0, I hope you would agree that that slope is roughly -1, right? I'm going down 1, right 1, down 1, right 1, okay? So it's going to be roughly -1 through this area here. Okay, and then it's also important to note too that in the section from -2 to 2, our graph function, the slope's negative. Okay, so that's going to be below the graph. So it's going to be below right about here. Okay, and our function goes all the way from -3.5 to 3.5. So I'm going to keep increasing to about 3.5. and up here to about 3.5. Okay, all right. Antiderivatives. So an antiderivative is the opposite of a derivative. It's going backwards. Okay, and an antiderivative, you can go from a function f prime to f. Now, what we're going to do, here's our step process. We'll make an f prime number line by using the location or the position, and that's highly important, the position of the points on the f prime graph. This does not involve the slopes of f prime. Okay, so slopes factor into it not at all. Okay, then what we'll do, we'll make an f prime number line by using the slopes. So we only look at position first, then we'll look at our slopes. Okay, and to make a f double prime number line. And then number 3, combine the information from this to give us our graph of f. Now it says, note, if no starting point is given, you are free to shift the graph vertically, and we'll talk about that in example 2. So example 3. So let's go ahead and look at this example. And let me use red. So I have f prime here, okay, and I want to look at the position. So what I'm going to look at first is my zeros. So first I'll make note of zeros. Those are our key important values. Okay, so I have a 0 here at -3.5, at 0, and at 3.5. So on my f prime number line, we have -3.5, 0, and 3.5. Okay, and in between these intervals, note that my f prime is positive. Okay, so my graph is above the x-axis for all of these values. Okay, so that means in this interval, f prime is positive. Now it becomes negative on the interval 0 to 3.5, so I write negative right here. Okay, so that's just position, right? All we did was analyze position for that graph. Now what we're going to do is we are going to analyze the slope for f double prime. Now here is where we do analyze the slope, okay? So I'm going to go ahead and look at this. Whoa. Control Z. Okay. I'm going to look. Hey, when it does this. Stay. Okay. All right. So I'm going to look at -2 and at +2. And again, note how at -2 and +2 that the slopes there are 0. That's a max and a min. Okay, and what we're going to look at now is the slope of f prime. And notice between -2 and 2, our slope is negative, and outside of that interval, it's positive. Okay, now I'm going to go ahead and graph f, and I want to interpret these graphs, these sine number lines. So if f prime is positive, that means my function is increasing. If it's negative, it means it's decreasing. Okay, and right here, this tells me that this is a max. We went from positive to negative. Okay, on f double prime, going up, that means it's concave up. Going down means it's concave down. And then positive means it's concave up. Okay, and what we learned is when we go from concave up to down or down to up, we have inflection points. Okay. So I have my information. Let's go ahead and plot this. Now note they say that make us a graph of f with a starting point 0, 1. So that kind of helps us out. At 0, 1 I have a point, and I know that this is a max, right? Because of my increasing, decreasing. So my function is increasing from -3.5 to 0 and decreasing from 0 to 3.5. And we know that our graph from -2 to 2 is concave down. Okay. So we'll go ahead and so from -2 to 2, it's concave down. All right, and at 3.5, right about here, and here, it is concave up. Okay, so note that this matches our graph, right? From 0 to 3.5, we are decreasing, and from -3.5 to 0, we are increasing. Okay, and here's a rough sketch of what this graph could look like. They don't tell us anything about the endpoints, where our max or our min or the absolute max or min are. So this is a rough sketch of the information that we do have. Okay, here is example 3. And on example 3, we have some interesting stuff going on. Okay, I have a point here, okay, of non-differentiability at 2, so that's important to note. Note that I have a 0 at -2, so at -2 that's 0, and over here it's negative and my function is positive over there. Okay, and we're going to go ahead and graph this. So looking at f double prime, okay, where this is the slope of f prime. Okay, so I'll draw a little arrow. This is the slope. So notice our slope from -infinity, it looks like, all the way to 0 is approximately 1. So right 1, up 1. Okay, so my f double prime line is going to look like this. And I'm going to leave an open circle at 0 because we have a point of non-differentiability. All right, and then our graph starts out really low and it's increasing like this. Okay, so that's going to be starting at 0, and then we have a straight line. Okay, so that kind of looks like a parabola, right? Something like x squared. And if I asked you, okay, what's the derivative of x squared? That would be 2x. That's a straight line. So there is our f double prime graph. And now we're going to go backwards. Oh, wait. Well, I forgot the F prime. F double prime line. F double prime line. So at well, this whole graph is positive. You agree? F double prime, everything's positive. Okay, so that means it's our function graph is always going to be concave up. So no points of inflection. No points of inflection. Okay, and we're going to go ahead and now graph this. So at -2, we switch from decreasing to increasing. Okay, so our function's decreasing and always concave up. So I'll just pick this point, and it's always going to be concave up. Okay, and then I'm going to get to this point, and notice at this point we have a point of non-differentiability. Okay, so I think that could be like a vertical tangent line, and then we'll go up, something like this. Okay, all right. So there you have it. Note this is, right, they didn't give us a starting point, so this graph could be vertically shifted anywhere. So like it could be like here. Okay, or it could be somewhere down here. Something like that. Okay, so lots of different opportunities, and maybe this lesson is driving you wild if you're like a very like, this has to be the answer type of person. We're just sketching graphs that could be from information that we're given. All right, okay, that's it for this lesson. I'll catch you next time. Peace.